The first question here in the warm-up on add, subtract, and multiply rational expressions is what are the multiples of 8? So that means you just multiply 8 times 1, you get 8, and 16. And then that's 2 times 8. 3 times 8 is 24. And 4 times 8 is 32, and so on. So we could keep going forever. Those are multiples of 8. And then what are the factors of 8? Are 1, 2, 4, and 8. So in other words, what integers divide 8 evenly? What positive whole numbers divide 8 evenly? And then for these 4, you want to find the least common multiple of 4, 6, and 8. So the way you do that is take the largest number here and then multiply by 1. And 4 divides that evenly, but 6 doesn't. And then times 2, 4 divides that, 6 doesn't. So 16 and then 24. So number 1 is 24. So you take the largest number and multiply it by 1, 2, 3, and so on. And see if the other two numbers divided evenly. So 24 is divisible by 8, 6, and 4. Then when you have expressions, what you do is, so you look at the numbers first, 3, 15, and 15. So 15 divides all those. And then let me get the equation editor here. And then you do the highest power of x, which is x squared, and the highest power of y, which is y to the first. So the least common multiple of these three is 15x squared y. And then 4 is actually, it would be 4 times x plus 1 and 4x. So the least common multiple would be 4, and then you take the variable to the highest power x and the expression to the highest power x plus 1. So the least common multiple there is 4 times x plus 1, 4x times x plus 1. And then number 4, this is already in factored form, so you leave that. I'm going to factor everything. This is in factored form already. And then the second expression in factored form would be, let's see, the factors of 18, they give you a -1. It's not factorable. This probably should be, well, we'll just leave it like that. I should edit this and make this a 9 there. So this would all be multiplied together here, the way it is. I'm just going to leave it the way it is, and then that's probably what wasn't intended there. Probably wanted to put a 9 right here. All right, so the objective, students will be able to add, subtract, and simplify complex rational expressions. And how do we add or subtract rational expressions? In order to add or subtract rational expressions, you'll need to find the least common denominator. To find the least common denominator, factor the denominators if they can be factored. If there are variables multiplied together, take the highest power of each variable. If there are expressions multiplied together, take the highest power of each expression. All the expressions and variables multiplied together become the least common denominator. To add or subtract rational expressions, multiply numerator and denominator of each rational expression by the missing factors. In the numerator and denominator, combine like terms in the numerator. You can leave the denominator in factored form. So here's practice 1. Because there's already a common denominator and it can't be factored, that's going to remain my denominator. And then in the numerator, I'm going to have x minus 1 plus 2x plus 9, and then divided by, or the denominator is 3x plus 4. So now I just have to combine the expression in the numerator here. It's 3x plus 8 over 3x plus 4. And I'm finished there. I can take these parentheses away now that I have this written as a numerator and denominator. Slide 5, we want to factor the denominator there. And then we have a common denominator. So we want to combine the numerator, 7x plus 4. And then we're going to distribute this negative 3x plus 2. And then divided by, I'm going to factor this denominator. It factors into x plus 2 and x plus 1. So now combining the like terms in the numerator, 7x minus 3x is 4x. 4 plus 2 is 6. And then divided by x plus 2 and x plus 1. And I notice there's a common factor in the numerator, so I'm going to go ahead and factor that. So 2 times 2x plus 3 over x plus 2 and x plus 1. The reason why I do that is see if anything can cancel. It doesn't, but we'll go ahead and leave this in factored form now. And take these parentheses away here. All right. The rest of the practice, the direction is going to be add or subtract, rational expansion, find the least common denominator, and factor the denominators when possible. So we want to make the common denominator here 8x. So the LCD is 8x here. And then I look here If I want to make this an 8x, then I have to multiply that 5 times x there. So this would be in the numerator now, 5x minus 3 over 8x. And those don't combine, so let's go ahead and leave it like that. And then first I want to look at the denominators here. 4 times x plus 3 is 1, and the other one is x plus 3. Let me write denominators here. So that makes the least common denominator is 4 times x plus 3. And then I look for any missing factors here. Is none. So we'll just leave that one alone. So 2. Then plus 7. The missing factor there is 4. So you multiply by 4. And then the denominator is 4 times x plus 3. And then 30 4 times x plus 3. And then here, the LCD is just these two multiplied together. X plus 2 times x minus 5. So that makes, you're going to have to multiply 7 times x minus 5. It's the missing factor there. And minus 4 times x plus 2. And the denominator is going to be x plus 2 times x minus 5. So 7x minus 35 minus 4x minus 8 over the common denominator. And then combine like terms in the numerator. 3x minus 43 And you can take these parentheses away, right, if you like, in the numerator, but I wouldn't have them if I was writing it out with pencil and paper, but because I'm using the text or the equation editor here, I need to put the whole numerator in parentheses in order to get this to look like a fraction bar. And then in this one, you want to factor the denominators. So I can't do anything with y plus 5. And when you factor the other one, the factors of 10 that give you a 7 are y plus 5 and y plus 2. So the LCD is y plus 5 times y plus 2. And then you want to multiply the numerators by the missing factor. So 3, missing factor there is y plus 2. And there's no missing factors in the second expression, so plus y. And divided by the LCD. And then doing the distributed property, 3y plus 6 plus y over the common denominator. This looks like the other problem we did. So if I factor in the numerator, nothing cancels, but it's okay to leave this in factor form now. All right, slide 10. So the LCD here, x minus 3 times x plus 7. On the numerator, you're going to have 2 times x plus 7 minus 1 times x minus 3. And then on the distributive property, 3x plus 14 minus x plus 3. Combine like terms, x plus 17 and then the denominator's factored here. So you have 5 times x minus 4 and x minus 4. The LCD, then 5 times x minus 4. So you want to multiply. 2, you don't have to multiply by anything. There's nothing missing there. No missing factors there. So 2. And then plus 7 times the missing factor, which is 5, over the common denominator. If 2 plus 35 would be 37. So 37 over 5 times x minus 4. So denominator's factored. Can't factor the first one. So x plus 3. And the other denominator factor is x plus 3 times x plus 4. Let's see, b. X plus 3 times x plus 4. So 3 times x plus 4. And then plus 2x. Divided by x plus 4 times x plus 3. Three x plus 12 plus 2x. So 3x and 2x is 5x. Plus 12. 6 plus 4 times x plus 3. And then multiplying rational numbers, factoring the numerators and denominators simplifies / cancel the like factors in the numerators and denominators, and you may leave the expression in factored form. So factoring the numerator and denominators here. First expression is x minus 3 times x plus 3. And then factoring the denominator, x times x minus 3 and times x over x plus 6 times x plus 3. So here the x plus 3's cancel, and the x minus 3 cancels, and the x cancels. So what are we left with? 1 on the top. And on the bottom, you're left with x plus 6. So it's hard to illustrate here, but you would cross these off, and cross the x's off. And so with everything on the numerator is crossed off, so you have a 1 here, and the only thing left not crossed off in the denominator is x plus 6. And then this one, and x squared. And then back to the denominator, x plus 6 times x plus 6. And the numerator factored. So here the x plus 6 crosses off once, the x goes away. And so I have 9 x squared over, one of the x plus 6 goes away, so over x plus 6, or 12 times x plus 6. You can simplify 9/12. Both of these are divisible by 3, so I got 3x squared over 4x plus 6. And then 16, factor and everything. This numerator factor the x times x minus 1. And this numerator factor the denominator here. And this factors again, so let me write this out. X times x minus 1 divided by x plus 5. And then is x squared. And then x squared minus 1 factors the x minus 1 times x plus 1. So x plus 1, x minus 1 goes away. One of these x is going to go away. There'll be 1 left in the denominator. So you have x plus 4 in the numerator. And in the denominator, x times x plus 5.